right, welcome to video C3. In this video, we're going to use the form we're given. So we're going to focus on using the form we're given and identifying what information we can extract from that given form. So our learning goal is just to be able to choose an efficient strategy by noticing what a quadratic form already tells us, and then therefore we can kind of determine, do we need another form or not, right? So pick the information out of the form, not necessarily just kind of close our eyes and expand and hope for the best. Okay, so hook. First thing I want you to look at those three equations, functions f, g, and h, and just kind of notice like what can you see from each of them. So without expanding, what do you know about them? What do you not know? And then what might you need to solve a question using those three functions. So pause the video there, take a shot at them, and then we will kind of reveal those throughout the video today. Okay. So let's look at this first one. So in vertex form, we have f of x equals -2 times x minus 3 squared plus 8. So we want to find just a bunch of stuff. So find the vertex, axis of symmetry, direction of open, max, min, range, y-intercept, x-intercepts. Okay. So, I mean, we call it vertex form. Like we know we see the vertex from this one, right? So when I have f of x equals -2 x minus 3 squared plus 8, I know immediately the vertex, which is arguably the most important point on the quadratic. So the vertex is 3, 8, done. What that then gives us, axis of symmetry, is going to be that x portion of the vertex, but it is an equation, right? So the axis of symmetry is x equals 3. Direction of opening, direction. We can see it opens down because we see that a value is negative. So a is negative, therefore open down. That then tells us, if I made a really quick sketch of this thing, so I have a vertex at 3, 8, and I open down, I can see I'm looking at that. So that must be a maximum. So going to the next question, max or min, we have a max at 3, 8. So we would say the maximum is at that point, or the maximum is y equals 8. That then also gives us the range. So we have a max y value, so our range is going to be, so y is an element of everything up to 8. Done. So in vertex form, we just kind of go right across, like bang, 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 bang. Now, this last two, we don't know these last two. So y-intercept, first of all. So y-intercept, I don't know, but I'm kind of going back to video C2 where I know it's an intercept. So I know the value is going to be that 0, c. So x is 0. So all I need to do is put an input of 0 into my function and return the y value, the output. So is what I have. So I put 0 in for x. So f of 0 is going to be -2 times -3 squared, which is 9 plus 8. So f of 0 is -18 plus 8, which is -10. So therefore, we have our y-intercept there, which is 0, -10. Done. Now notice I could have got the y-intercept from standard form, but I didn't need it. I don't need to expand that quadratic out from vertex form to standard form. I can just use my given form, vertex form, to go find the y-intercept. Finally would be x-intercepts. So x-intercepts, well, I know, again, intercepts, so they're coordinate points. So x-intercepts are going to have some x value, but I don't know the y value. Or I don't know the x value. I do know the y value is 0. So for a function, what that means is, hey, put in 0 for y. So I know f of x is 0. The output is 0. So put 0 in the output spot, and then go back and find what the inputs must have been. So I get this. Now this calls back to video C1. I'm in vertex form. I don't need to expand that and try to factor or use the quadratic formula. I can solve directly from here. So I'm going to isolate my square. Here's my square. I'm going to isolate that. So subtract 8 divided by -2. I'm going to get 4 equals x minus 3 squared. I'm going to square root both sides, and that's going to give me x minus 3 equals plus or minus 2. Remember, I introduced the square root. I could add it if I wanted. I introduced a square root, so I need to include the plus or minus. And then finally solve, right? So x is going to be 3 plus or minus 2. So that gives us x equals 3 minus 2, which is 1, or 3 plus 2, which is 5. Now here again from video C2, I want the x-intercepts. So I'm going to say those points. So the x-intercepts are going to be 1, 0, and 5, 0. And that's it. So again, you can see I just use vertex form. I don't need to expand it out, go to standard form, and then come back through factored form. Vertex form is the dream. Like I can find everything pretty quickly from this. So looking at the solution, now ask yourself again, what did that form show us before any expansion? So if you went back through the list, you can see the check marks, right? So vertex, axis symmetry, direction of opening, max, min, and range are all directly readable from vertex form. Okay, let's look at another question now. So this one's for you. So this one says, hey, g of x equals 2 times x minus 1, x minus 5. Now, for this question, what are the x-intercepts, axis symmetry, vertex, direction of opening, max, min, range, and y-intercept? So all the same things. So you can pause the video in a second. Remember, the roots are visible here. Try the problem and see what you can get without necessarily changing forms. And here you go. So if you take a look at this, you get a lot of take a look at what you have. Very similar information, but we did have to work a little harder here, right? So we had our x-intercepts visible. We had our direction of opening visible. Axis symmetry I can find because I know a parabola is symmetric. So I just go halfway between those roots of 1 and 5, and then I can plug that back in for the vertex, and then I have the range, and I can get the y-intercept by plugging in. Right now, it was a little more work, I think, but we could still do it without necessarily changing forms. And again, a little reveal note, how do the midpoint of the roots help? Midpoint of the roots is axis symmetry because parabolas are symmetric. I'll write that down. So parabolas are symmetric. And that's it. Okay. Last one. Example 3. What if we're in standard form? So let's take a look at this one. So I have h of x equals x squared minus 6x plus 5. Find the stuff from standard form. So standard form is probably the least useful for us directly. From the form itself, without doing any work, we know the y-intercept. So I know right away the y-intercept is going to be y is 5. Now it's an intercept, so I'm going to state it as a coordinate pair, 0, 5. I can again see a of 1. So I know the direction is, so a is positive, so it opens up. Open up. Now what that tells us is the vertex here will be a minimum. I don't have the vertex though. So next one's going to be axis symmetry. So for axis symmetry, I could complete the square and go to vertex form, but I don't need to. Like that's probably overkill. So what I'm going to do is axis symmetry. I can either A, find 2 points with the same height, such as the x-intercepts down here, or I could use my shortcut, and I'll use a shortcut here. So I know the x part of the vertex, or the axis symmetry, same thing, is going to be negative b over 2a. And remember, standard form is y equals ax squared plus bx plus c. So b is negative 6. So negative b is going to be 6. A is 1, so 2a is 2. So the axis symmetry is going to be x equals 3. There's the equation. So when I go up to my vertex now, so my vertex, x part of the vertex is 3. We just got that. Y part of the vertex is going to be what's h of 3. So h of 3 is going to be 3 squared minus 6 times 3 plus 5. So that's 9 minus 18 plus 5, which is negative 4. So therefore, the vertex as a point is going to be 3, negative 4. Finally, I want my x-intercepts. So x-intercepts, again, I could go to vertex form and then solve it directly, or I can just kind of solve from this form. So x-intercepts, I know y is 0. The output 0. So I'm going to take my function here, plug in 0 for my output, and solve for my input. So x squared minus 6x plus 5. So here I'm going to solve by factoring. So I'll say, well, I know this factors into x minus 5, x minus 1. So x minus 5 is 0, or x minus 1 is 0. So that's x is 5, or x is 1. So my x-intercepts, again, stay them as points. X-intercepts are going to be 1, 0, and 5, 0. And that's it. So I have all my information here. And I'm done. Okay. So wrapping this up, little checklist. Things we're kind of looking for from our forms. So first one is, again, vertex form. So if I see something in vertex form, so that's y equals x minus h squared plus k, things I'm looking for directly from that form. So I know the direction. I know the direction of opening, which is A. I know the vertex, which is hk. Because I have the vertex and direction, I know if I have a max or a min on that vertex, and I can also easily pick the range off. I could pretty easily solve for the x-intercepts. It's not direct though, so I won't list it. If I have factored form, so if I have factored form, a, x minus r, x minus s, factored form tells me my direction again. I can always see that a. And I also have the roots or x-intercepts. So the roots are going to be x equals r, x equals s. X-intercepts would be the coordinate pairs. Again, I could find the axisymmetry using that symmetry, 2 points the same height and divide by 2. But that, again, is not direct, so I won't list it, but I do have it pretty quickly. Finally, standard form. So standard form, I again have that direction of opening of A. Is it positive opening up or negative opening down? And I have the y-intercept. So I have the y-intercept, which is going to be 0, c. That's pretty much it. Now we do have, it's a little bit of work, but I will just list it to kind of keep things, I don't know, it's not all bad. Axis symmetry is going to be x equals negative b over 2a. That is a bit of work, but then I can kind of start working towards my vertex and my roots. And I mean, the big thing is don't expand unless you need to. The question is going to dictate what you have, right? So just try to follow the question. Don't try to make this thing formulaic and kind of one size fits all. Really take what the equation's given you. If you need to change forms, but there's a very good chance that you don't need to. Okay, that's it. Thanks for watching.